Hello, boys and girls, and welcome to another wonderful week of math for first grade. This week, we will be working on representing numbers. Our objective will be that I can represent whole numbers up to 120 using concrete and pictorial models. Boys and girls, my name is Mrs. Ward, and I am a kindergarten, first grade ESL teacher for HISD and one of HISD's Mint Teacher Leaders. For today's lesson, you're going to need your pencil, your paper, a positive attitude. We will go through our introduction, our warm-up, vocabulary, number of the day, and our math lesson. In today's lesson, we will be taking a look at representing numbers up to 120 using concrete and pictorial models and standard, word, and expanded form. Are you ready, mathematicians? Let's jump into today's math lesson. We're going to begin today with our number talk. I want you to take a look at the number that I have on the screen. I want you to think about what number is it that you see. I heard some people set the answer right away. Some of us need a few more seconds to figure it out. What did you come up with for your answer? You should have came up with the number 25. Here we see the number 25. And I'm going to write 25 with the digits 2 and a 5. But how did you come up with 25? Did you have to count each dot to get to 25? You could have counted each dot to get to 25, and you would have counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. If you counted each dot, you would have gotten the number 25. But is there an easier way to find this number or a faster way to find the number? Did anybody else try something different? We have talked about 10 frames in the past. You may have noticed that here we had 10 frames and then we had some dots by themselves. A 10 frame is a box that has 2 rows and each row contains 5 for a total of 10 spaces. So you may have known just by looking that this group is representing 10. And because we know how to skip count, we knew that this was 10. And since this 10 frame is filled, that means this is 10, 20. But then we had some left over. So here we had 10, 20, 21, 22, 23, 24, 25. So maybe you had to count each one. Or maybe you counted 10, 20, and then added the 5 ones. Maybe you knew by looking at this picture that this represented 5. So you may have counted 10, 20, 25. All of those are correct. It just depends on the way that you saw the number. How did you see the number 25? For our vocabulary today, boys and girls, you're going to be hearing terms like compose. We have heard the word compose before. We know that when we compose, it means we're putting the number together. What's the word? Compose. What does compose mean? To put the number together. If compose means to put the number together, can you figure out what decompose means? Compose means to put the number together, and decompose means to take the number apart. When you decompose a number, you are taking the number apart. You might also hear the word digit. Digit is representing a number. It can be a number from 0 to 9. Another vocabulary word you will hear is expanded form. Expanded form means we're taking the number, decomposing it, or taking it apart, and then adding the value of each digit so that we can compose the number. And the last vocabulary term you might hear is the word form. And word form means to represent a number using words. Here is some of the place value that you will need to review for today's lesson. We have seen place value blocks in our previous lessons. We know that this small, tiny square is representing the value of 1. This little box represents 1. This stick is representing 10. When we take the 1 and stack it together, if we take 10 ones, it equals 10. So this one stick equals 10. When we see the flat square, it is representing 100. And boys and girls, when you go on to second grade, you will see this cube, and it is representing 1,000. But for today's lesson, we will be looking at our ones, tens, and 100s. Let's take a look at our problem of the day. In our problem of the day, I want you to identify the number represented in this model. Think about that number talk we did. We know there is more than one way to find the answer. What number do you see in this model? Take a few moments to find your answer and then write it on your paper. What did you get for your answer? And how did you get your answer? First, let's take a look at what do we see. When I take a look at this problem, I see those place value blocks, tens and ones. I know when I see them stacked together that this represents 10. Because I know that this represents 10, I know that I can start by skip counting by 10. So here I have 10, 20, 30. Now, when I looked at the number, I knew that it was easier to skip count by 10. So you may have looked at the ones and looked for another group of 10. Or you may have counted each one by itself. If this is 10, 20, 30. Then we had 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. So here, the number represented in this model was 46. Did you get 46 for your answer? If you didn't get 46, count it again. The correct answer was 46. If you got 46 for your answer, give yourself a silent cheer. We said, boys and girls, that this number was 46. We said we could write 46 with the digits 4 and 6. In the number 46, we saw 1, 2, 3 tens, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We saw 3 tens and 16 ones. 3 tens and 16 ones. But is there another way that we could show 46? How could I use place value blocks to model 46 other than 3 tens and 16 ones? I remember in a previous problem, we said when we have ones, we could group them together if we have 10 to make a 10. Let's count and see if we have enough to make another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to put a circle around these to show that I could put them together in a group of 10. Let's see if we have enough to make another 10. 1, 2, 3, 4, 5, 6. Did we have enough? No. So how many tens did we have in all this time? 1, 2, 3, 4. So this time we had 4 tens. And how much is 4 tens? Let's count it. 10, 20, 30, 40. And how many ones did we have left over? 1, 2, 3, 4, 5, 6. So that means I could also represent the number 46 with 4 tens and 6 ones. So 3 tens and 16 ones equals 46. But 4 tens and 6 ones also equals 46. Let's double count it to make sure. 10, 20, 30, 40, 41, 42, 43, 44, 45, 46. So one way that we showed the number 46 was 3 tens and 16 ones. Another way that we showed the number 46 was 4 10s and 6 1s. So we know there is more than one way to show a number. In today's lesson, we will be looking at different ways to show a number using concrete models. We just worked together to show the number 46. I want you to spend the next 2 minutes and write down how many ways you could show the number 37. How could you use place value blocks to make a concrete model to show the number 37? I want you to think about it. Remember, there is more than one way to show those numbers using place value blocks. Are you ready? Here's your 2 minutes. Draw on your paper the number of tens and ones that it would take to make 37. Remember, try to come up with more than one way. You can do it, great mathematicians. How can you model the number 37 using tens and ones? And can you come up with more than one way? You have a little less than 1 minute left. You can do it. And boys and girls, you know what that sound means? It means our time is up. So on your paper, you should already have at least one, if not two, or more ways to show the number 37. Let's look at it. One way that we could have shown the number 37 is 1, 2, 3 10s, and 1, 2, 3, 4, 5, 6, 7. One way to show the number 37 was 3 10s and 7 1s. Let's count it and make sure that's correct. 10, 20, 30, 31, 32, 33, 34, 35, 36, 37. So one way that we made the number 37 was 3 10s and 7 1s. Did you find another way to show the number 37? You also could have showed the number 37 with 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. And I'm going to put a line to separate them just so you don't get confused. So I also could have showed the number 37 with 1, 2 tens and 17 ones. 2 tens and 17 ones also equals 37. Is that what you drew on your paper? Did anybody find another way to show the number 37? And I'm sure yours is much neater than Miss Ward's. I was writing on the screen, so mine didn't come out as perfect as I like it. But I just want you to try your best. For our guiding question today, we want to think about how can you use pictorial models to represent a number? Look at the picture we have here. Do you see any ones, hundreds, tens? What number do you see represented here in this picture? I know we said this square equals how much? That's right, it equals 100. And this bar is, each one is 10. So if this is 100, oh, my pen didn't want to write. This is 100 plus 10 will give me 100, 110, and 10 more is 120 because I had 100, a 10, and another 10. So the number that's being represented here is 120. So what did we use to show 120? So the number being shown here is 120. Look at this model. What number do you see in this model? Take a look at how many tens do you see? How many ones do you see? We have seen these place value blocks, so we know each of these bars is representing 10. So we can find the answer by counting these bars by 10. And we know these boxes, each box is representing 1. So if we want to count it, we see that we have 10, 20, 30, 31, 32, 33, 34, 35, 36. So what number do you see represented here? Here we have the number 36. When we look at the value, how many tens did we have? And how many ones did we have to make this number? We use 3 tens and 6 ones to make the number 36. Well, if I want to put it in expanded form, How much is 3 tens? 3 tens is 30 plus 6 ones is 6. So 3 tens and 6 ones gives me 36. So that means I can add 30 plus 6 equals 36. So if I want to put it in expanded form, that means I'm adding the value of each digit. So I know the 3 is representing 30 and the 6 is representing 6. So 30 plus 6 equals 36. Look here, what number is represented? What changed in this problem? Before, we only had tens and ones. In this problem, we have hundreds, tens, and ones. How many hundreds do you see? How many tens do you see? How many ones do you see? I know that this square is representing 100. This bar is representing 10. And here I have 2 ones. So if I put it together to find the answer, I have 100 and 10 more is 110, 111, 112. So the number I have represented here is 112. How many hundreds, tens, and ones did it take to make 112? 100, 110, and 2 ones. If I want to put that in expanded form, I know I have to add the value of each digit. So I know 100, 110 is going to be 10, and 2 ones has a value of 2. So if I want to put this in expanded form, I would put 100 plus 10 plus 2 equals 112. And now, boys and girls, it is time for you to try it on your own. Today, we learned about using pictorial models to represent numbers up to 120. On your own, I want you to represent the number 108 using place value blocks. That's what I want you to practice on your own. If you want to give yourself an extension and really be a superstar, you can show the number 108 using place value blocks more than one way. You can also show the number 108 in expanded form. So on your own, I want you to represent the number 108 using place value blocks to make a pictorial model. Remember, you can show 108 in more than one way with place value blocks. And lastly, I want to thank you for joining in with me today. Miss Ward enjoyed working with you, and feel free to go and follow me on Twitter. On Twitter, I am listed as Ward Sandy 5. Again, that is Ward Sandy 5. Can't wait to see you next time.